No coffee. Same rules. Hello and welcome back to Statistics1. Chapter 2, we organized a whole bunch of data. Now we would like to learn a little bit about distribution shapes. It's a really quick lecture. So we start by writing down the definition of distribution. So the distribution of a data set is a table, graph, or formula that provides the values of the observations and how often they occur. So all of the charts that we had in the previous lectures with the display data were distributions. And the goal of today is to learn about different shapes that those distributions take. Now, shapes in terms of the graph. We've seen the histogram. And when you have a histogram, you can snake the line through the top of the histogram and then look at the shape of that line. So now we're going to learn some names for the shape of that line. For instance, if I am to have example. So if I'm to have a histogram that looks something like this. Let's go 2 up, 3 up, 4 up, 6 up, 5, 3, another 3, and let's say a 2. X-axis and Y-axis, doesn't matter. So let's say this is your distribution. We know that there was some data. We created those categories, let's say 20 to 30, 30 to 40, or 100 to 200, 300, whatever. Whatever the x-axis is. So we have the histogram. See, I can draw approximate line that goes through the top of this, right? The pink line I drew is not perfect, but there is no such thing as perfect in statistics. Good enough is good enough, all right? So when you snake this pink line through, we'll learn the names of the pink lines that you can draw. Because the data is going to give you the histogram, and through the top of the histogram boxes, you would be able to draw some of these shapes. So the first category that we observe is the category for modality. Meaning number of peaks. We can have one peak, 2, or many. Unimodal, bimodal, and multimodal. So the one that I have on top in pink is definitely unimodal, meaning one, uni. Uno, right? And then B, bimodal, it's 2. Usually, this is what happens with grading eventually in most of the classes. There is the concentration of students doing great in a class and concentration of students doing not good at all, with this middle pretty much being deserted. So especially the higher you go in mathematics, like calculus 2, this is definitely the graph for calculus 2, because we have all of the calc 1 C's that are failing calc 2, and then we have all of the ones who have good prerequisites and able to work well. So when you receive the exam, and we're going to run these statistics on exam if you guys pick to have an exam, you look at this and you say, oh, all of the grades, you look at the distribution, right? That's all the grades on a pile. And if you see something like this, if you see a high number of students in 30s and 40s, and then you see high number of students in 80s and 90s. And then, all the other ones have 1 or 2. 2 students in 50s, 2 students in 60s, 2 students in 70s. It's actually very, very frequent to have these types of distribution. And something like this, I mean, if you've ever seen a stock market thing, there you go. It's just, So that's that part for modality. And then we have the symmetry. So the next one is important, so we're going to do the red. Symmetry. And this one has those that are frequently mentioned. Yeah. That's better. So the first one is called, you should all know this one, bell, exactly. Bell-shaped. The next one looks like a tent. I like the tent. We should rename the tent. I'm going to, no, I'm serious, I like it, tent. It's triangular, but tent, I like it. If you write tent on the exam, I'll have to accept this. Triangular and uniform. So these are now 3 more. Okay, so we have, good luck with this, right skewed, right? And left skewed. And the J one, J shape, reverse J shape. Said J. Just trying new stuff. All right. So that's it. These are the shapes. You have 6 of them to learn, and the uniform one has no mode, no modality. Pretty much everything else, and the J shape has no modality either. But the other 4 are all uni-shape, right? Unimodal. 1. So we have population and right? This can be done on population and on a sample. So whatever data you have, population data or a sample data, you will call this population distribution or a sample distribution, depending on what you have. So these shapes are for both sample and population distributions. Anytime when I say the word distribution, you are immediately thinking about the chart with data, right? Which is given to you, or you did surveys and came up with numbers. So let's see. And try to find something for Am I reading this right? Children of U.S. presidents. So information please almanac provides the number of children of each of the U.S. presidents, the frequency histogram of number of children by president through President Barack Obama, as follows, and there is the histogram. X-axis, number of children. A box over here that connects 14 to 16. Thomas Jefferson? 16 Busy. There will be 8 cents. 113? Was your grandpa 13?
No.
Would fit right here. Missed opportunity to make the chart.
He was President John Tyler. He had 15 children.
15. Well, that's right in the middle. Thank you. See, I'll have to sit down. All right. So, what type of distribution? Right skewed. Very good. So type of distribution would be right skewed. So the problem in a book 2.140 is we have a histogram. I'm going to just loosely sketch this thing. I'm not going to draw the exact. There's no need. So this is what data looked like, going from 0 to 16, and I'm just going to use the pink to snake the line through, and this is the only thing you need to do. You draw a line, the pink line that I have, so you just try to hit as many as possible. So here we go. Panic, this one. I know I missed these, but you can't really get everything perfect. So there you go, and you told me right skewed, which is correct. Done. Problem solved. Well, that's it. Bye.